This is the full section of chapter 3 on continuous distributions, and this section is on the mode, median, percentiles and skewness. So let's first of all start with how we find the mode. So the mode of a continuous random variable is the maximum value of the PDF. Now this is the highest point on the graph of the PDF, so we should always sketch the PDF and that will make it clear where the highest point is. Now we could find the highest point visually by reading off the graph, or it may be that we need to differentiate and find when the gradient is 0 or complete the square. So there may be other methods, but I would always draw a sketch, and that makes it much easier to see where the PDF or the maximum of the PDF is. Next we'll look at the median. And the median of a continuous random variable is the value of m where f of m equals 0.5. Now remember, capital F like this is the cumulative distribution function. So we want to find a value here where the value of the cumulative distribution function is equal to 0.5. Next we'll look at quartiles and percentiles. Now for the lower quartile, it's where the value of the cumulative distribution function is equal to 0.25, and we need to find out this value here, Q1. For the upper quartile, so that should be Q3, is going to be where the value of the continuous distribution function is equal to 0.75, and we'll need to find the value of Q3 here. Obviously, if we want to find the interquartile range, then it's the difference between Q3 and Q1, Q3 minus Q1. And for the nth percentile, then it's where the value of the cumulative distribution function is equal to n over 100. And this represents the nth percentile here. And again, we'll need to work out what this value is to find the value of the nth percentile. And lastly, we'll look at skewness, and there's 3 types of skewness. The first type is what we call a positive skew. That's where like the data seems to be bunched up towards the left-hand side. Now I've drawn a curve here. It could just as easily have been a sort of straight line. So it could be, let's say something like this. We've got sort of a piecewise function. So either one of those would be a positive skew. And if we want to identify a positive skew, then this statement here is true. Now the way to do it is to write these words in alphabetical order. Mean, median and mode, they're in alphabetical order. They're the 3 we're going to compare. And positive seems to imply greater than. So the mean would be greater than the median, would be greater than the mode. Now we only need to compare just 2 of these to show that something is a positive skew. So for example, if we find that the mean is greater than the median, we can say it's a positive skew. If we find the median is greater than the mode, we could say it's a positive skew. Or even if we say that the mean is greater than the mode, it's a positive skew. So alphabetical order and then greater than symbols will tell you that it's a positive skew. For a negative skew, we'll find that the data sort of seems to be bunched up toward the right-hand end. So the mode is going to be over to the right-hand side rather than the left-hand side. Again, these don't have to be curved like this. It could be straight lines. So it could be I've got a piecewise function that's something like this, where the peak is over here. And again, if we write the words in alphabetical order, mean, median and mode, negative seems to imply less than. So the mean is less than the median, is less than the mode. Again, compare any 2 of these will tell us if we've got a negative skew. So for example, I find that the mean is less than the mode, I can say that it's a negative skew. And lastly, the last type is a symmetrical skew, or it's unskewed, or we say that there's no skew. So basically the peak is in the center. And for this one, the mean is equal to the median is equal to the mode. So again, we write the words in alphabetical order and we put equal sign because something is symmetrical. It implies that we should have equal signs between them. And again, this could be a piecewise function where I've got a straight line going like this and a straight line going down, again with the peak in the center, and this will be a symmetrical shape here. Example 11. The random variables x and y have probability density functions f of x and g and y respectively, so they're given here. What we want to do in part A is to find the mode of x, so the mode of x. So whenever we're finding the mode, we should always do a sketch of the graph. So the first thing we're going to do is we're going to take this function here, multiply it out to see what type of function we've got. So we've got f of x is equal to 12x squared minus 12x cubed. So that tells us it's a cubic, and it's going to be a cubic that goes in this type of direction, like that. So we need to work out what part of this graph it's going to be. So we can maybe just work out a few values to get some sort of rough sketch. So for example, when x is 0 here, this function is going to be 0, so we know it's going to start here. And then when x is 1, we're also going to have 0, so we'll just mark something over here like this. Okay, so what I've done to help me sketch this is I've used my calculator, I've used the table function, I've put in this as the function, and I've gone from a start of 0 to a finish of 1, and I've gone up in 0.1s. And just scrolling through the values, I can see that it reaches a peak, or the largest value I get from the table is at 0.7. So the larger value is closer to 1 than it is to 0. So it's not going to be something that's sort of symmetrical like this. It's going to be where the peak is slightly over towards the 1. So a sketch might look something like that. So that means that we've got sort of this part of the graph here. Now it doesn't matter too much whether it's completely accurate or not. It's only meant to be a sketch, and it's meant to give us some sort of idea of where we're going to find the mode of this, where we're going to find the peak of the PDF. Now we know that the mode of the PDF is going to be equal to the maximum of the PDF. So this is not something we can just read off or easily see from here. So what we're going to do is we're going to differentiate it to find the maximum. So that means we're going to differentiate f of x and find out where that equals 0. That will tell us where the maximum is. So we differentiate 12x squared minus 12x cubed. We want to find out when that's equal to 0. So that will give us 24x minus 36x squared. And when does that equal 0? Well, that will give us 36x squared is equal to 24x. If we divide both sides by 12x, then we'll end up with 3x equals 2, and x is 2/3. So that tells us that the mode is equal to 2/3. So it was easier just to find out when d dx is equal to 0, and that will tell us where the mode is, where the highest point is. So that actually is telling us that this point here, that maximum, if I were to plot it, and I was to go down like that, that's actually at the point 2/3, which is what we'd expect from our sketch. We said it was closer to 1 than it is 0. And if we go back to our table and actually look between 0.6 and 0.7, so 0.6 from the table is 1.728, and then 0.7 is 1.764. So the maximum could be somewhere between those two, which it actually happens to be 0.6 recurring. Moving on to part B, and we want to find the mode of y. So again, we're going to draw a sketch. So this one's nice and easy because it's just a linear function 2y. So that means it's going to start at this end here when y is 0, g of y is 0, 2 times 0 is 0. And then at the other end, where we've got y equal to 1, then g of y is going to be 2. So we'll put those points in. So over here, so 0 here, we'll make this point 1. And then here, we'll make this point here 2. And then we can just draw our line in, which is going to go up to that point there. So we're going to have something like that. Now, I don't need to differentiate this. Remember, we're trying to find the y where g of y is a maximum, and I can see it's here. Yeah, that's the maximum value. That's the highest point of the PDF, and it occurs when y is 1. So, very easy. Mode is equal to 1. So that's the advantage of drawing a sketch, is that if it's linear, for example, it's going to be very easy to find the mode. Look for the highest point. If not, use differentiation, and we know that the gradient here is 0, and that occurs when x is 2/3. That's why we got a mode of 2/3 there. Okay. Example 12. A continuous random variable x has this probability distribution or density function here, and in part A, we want to find the CDF of x. Now remember, to find the CDF of a function from the PDF, then we need to integrate the PDF. So we're going to integrate this with respect to x. Now remember, when we integrate it, we're going to have a plus c, and then we can use a value of x to work out what c is. Okay, so we want to integrate 4x minus 4x cubed with respect to x. So 4x integrated will be 4x squared over 2, so 2x squared, and minus 4x cubed will be 4x to the power 4 over 4, which will be x to the power 4 plus c. Now we can use one or two values to find c. So for example, we know that when x is 0, the probability is 0. So we know that f of 0 equals 0. We also know that f of 1, this value at the other end, equals 1. The probabilities are between 0 and 1, and probabilities go from 0 to 1. So we know that when x is 1, the probability is 1, or we know where x is 0, the probability is 0. So let's just use this one, the f of 0 equals 0. That's probably going to be easier. So let's just write down, since f of 0 equals 0, then when x is 0, we'll get 2 times 0 squared minus 0 to the power 4 plus c equals 0, and so that tells us that c equals 0. So that tells us that the CDF, capital F of x, is equal to 2x squared minus x squared, or x to the power 4. Now remember, we need to write this using a proper notation. We need to show what's happening for all of the different values of x. So I have f of x equals, then we'll have our curly brackets like this. So what numbers are missing? Well, when x is less than 0, so anything when less than 0, the probability is 0. So here we go, 0, that's for when x is less than 0. Now, when x is between 1 and 0, including 1 and 0, then the CDF is going to be this. So I might need to move this over a bit. Let's write down the 2x squared minus x to the power 4, and that's for these values of x, 0 and 1. And then we need to say what happens when x is greater than 1, or when x is greater than 1, the probability is 1. So don't forget, don't just work out what f of x is. We need to put it into this format here as a final answer for the CDF of x. Right, now we'll move on to part B. And part B is asking us to find the median value of x. Now remember, that's where the CDF of x is equal to 0.5. In other words, we get the median when f of x equals 0.5. Now, we should really use the letter m when we're talking about the median. So I'll put m, all of that. That just means that when I write the equation down, instead of writing 2x squared, I'll write 2m squared. Instead of x to the power 4, m to the power 4. And I want to know when this equals 0.5. So the rest of the question is just about trying to solve this equation. So let's write it as m to the power 4. So we're taking that to the other side, minus 2m squared plus 0.5 equals 0. So if you think of this like as a special quadratic, actually when we use the quadratic equation, it's going to be m squared equals rather than m equals, because if we were able to factorize this, it would have this m squared at the beginning of both brackets, and there'll be some sort of number here. But this can't factorize. We can't find two numbers that multiply to give me 0.5 and subtract to give me 2. So I'm going to use the quadratic equation. But I will say m squared equals minus b, so minus negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, 1 times by c, which is 0.5, and all of that is going to be over 2a, 2 times 1. Okay, so what does that give me for m squared? So simplifying, I'm going to get 2 plus or minus, this is going to be 4 minus 2, so that's just 2, and then the square root of 2 all over 2. So if I want to find m, because remember we've got m squared, that's going to be equal to the square root of all of that, plus or minus the square root of that, 2 plus or minus the square root of 2 over 2. So the values of m that we get, one will be 1.30656 and so on, and the other value of m is 0.54119 and so on. Now remember, when we're finding the mode, even though we put m here, we're finding a value of x, and we use this function here to find the value of x, the mode, and it's got to be between 0 and 1. So that means we can discount this onto here, because that value of m is not between 0 and 1, so that's no good. So our final answer for the median, sorry, I said mode, I meant median, is equal to, and I'll give it to three significant figures, 0.541. Okay, so there's just one or two things there you need to watch out for. Make sure on something like this, we've got m squared, that you square root it, and that the value you get for the median is in the range of x for the CDF that you're using, especially if you've got a piecewise function where you may have more than one row of working that you need to do. Example 13. A continuous random variable x has this cumulative distribution function here, and two parts to this. Part A, we want to find the interquartile range, and in part B, we want to find the 10th percentile. So if we want to find the interquartile range, we need to find the value of m that gives us this, and we want to find, oh sorry, Q3 that gives us that, and subtract the value of Q1 that gives us this, and that will give us this interquartile range. Now remember, if I want to find the upper quartile, that's the value of Q3 for which I get a cumulative distribution function of 0.75. The value of Q1 is where I get a cumulative distribution function value of 0.25. So I need to know, where am I going to find CDF of 0.25? Is it going to be in here or here? And where am I going to find a CDF of 0.75? Because I need to use the right set of algebra. Okay, there's no point using this to find Q3, for example, if I don't get a value of 0.75 between values of x between 1 and 2, for example. So we need to identify which one to use. So the way I'm going to do that is I'm going to add an extra column at the side here, which I'll call my CDF column, and I'm going to write here down here what the probabilities are and the values of x that give those probabilities. I'll show you what I mean. So on the first row, I know that when the if I want to know the probability of x less than 1, that's going to be 0. That's what the top row is telling me. Okay, for the next row, I want to work out, well, what's the probabilities or the cumulative probabilities between x equal to 1 and 2. Now this cumulative probability goes from a value of 0 to 0.2, and I'll tell you how I work those out. So it goes from 0 to 0.2. Now the way that I work those out is I put a value of 1 into here, so 1/5 times by 1 minus 1/5. So I'm starting from a probability of 0 at this end, and because it's cumulative, the probability is going to keep increasing. It won't go back down again. And to find the value at this end, I put 2 into this function. So 1/5 times by 2, which is 2/5 minus 1/5, which is going to be 1/5, which is 0.2. Then for the next row here, this is going to tell me the cumulative probability for x between 2 and 4. So again, what I'm going to do is to just substitute these values in. So when I put 2 into this, I'm going to have 2 squared over 10 minus 2 over 5 plus 1/5, and that gives 0.2. So it's greater than 0.2. So that's where the cumulative probabilities start. Where do the cumulative probabilities finish? Well, I just put 4 into this. So 4 squared over 10 minus 4/5 plus 1/5, and that will give me a value of 1. And then if I look at the bottom row, this is for probabilities where x is greater than 4. And we know that when x is greater than 4, the cumulative probability is going to be equal to 1, because obviously you can't have greater than 1. So what I've done here, this bit of information just tells me what the cumulative probabilities are for this CDF, and at a glance I should be able to see where I'm going to find the upper and lower quartile. So for Q3, it's where the CDF is equal to 0.75, so it's going to be in here because these cumulative frequencies go from 0.2 to 1. So I'll just put Q3 is in here, so I know what function to use. I'm going to use that to help me work out what Q3 is. And then for Q1 is where I find a cumulative probability of 0.25. Now that's also in here, so I'll just put so is Q1. So now we can start doing the working. So the upper quartile is going to be found where the CDF is equal to 0.75. And I've decided that it's going to be this function that I use to find the upper quartile. So instead of using x, I'm going to use Q3. So I will have this Q3 squared, rather than x, just use the right notation, divided by 10 minus Q3 over 5 plus a fifth equals to 0.75. So the rest is now about solving that equation. So we'll start by multiplying both sides by 10. So we'll get Q3 squared minus 2Q3 plus 5. Sorry, now I'm multiplying by 10. So that's going to be 2 equals 7.5. We'll take 7.5 away from both sides, and then we've got a quadratic. So minus 2Q3, and then we'll have minus 5.5 equals 0. Okay, and then what I'll do is I'll use my calculator to solve this. So I get 2 plus root 26 over 2, and I get 2 minus root 26 over 2. Now I can reject that one because that's a negative value, negative 1.549. So we'll just go for the positive one, and maybe I'll just write down the exact value and then I'll use that in my working. So 2 plus root 26 over 2. So now we're going to find Q1. Now we know that f of Q1 equals 0.25. We're using the same function, so it's going to be Q1 squared over 10 minus Q1 over 5 plus 1/5 equals 0.25. So we're going to be doing something similar. We'll times both sides by 10. So we'll get Q1 squared minus 2Q1 plus 2 equals 2.5. We'll take away 2.5 away from both sides. So Q1 squared minus 2Q1 minus 0.5 equals 0. And again, I'm just going to use my calculator to work out the value of Q1. So I get values of 2 plus root 6 over 2 and 2 minus root 6 over 2. Now the 2 minus root 6 over 2 is negative. I can reject that because x is not negative, so I'll write down the exact value and I use that in my working. So I've got 2 plus root 6 over 2. So my interquartile range is equal to 2 plus root 26 over 2, and then I'll just minus the 2 plus root 6 over 2. So the exact value I get is root 26 minus root 6 over 2. We can keep that as a decimal, and that's 1.3247 something like that. So 3 significant figures. So we'll go with 1.32 as the value as of our interquartile range. So let's just highlight that before we move on. Right. So part B, we're going to work out what the 10th percentile is. So P10 is where the CDF is going to equal 0.1, because basically that's going to be 10 over 100, like the n over 100. So where am I going to find CDF of 0.1? Well, it's not in this row, it's going to be the top row. So I need to use this part of the piecewise function to find the value of x. That's going to give me a CDF of 0.1. So P10 is in here. So now it's just a matter of using that equation, 1/5 x minus a fifth, using the right notation. So it'll be 1/5 p10 minus 1/5 equals 0.1, and that's going to be easy enough to solve. So I'll just do 0.1 plus a fifth, 0.2, which is 0.3, 3 over 10, then times that by 5, and I get a value of 3 over 2. So P10 equals 3 over 2, or I can give that as 1.5. So let's just highlight that there as my value of P10. Example 14. A continuous random variable x has PDF given here, so I can see it's a piecewise function. The first thing I want to do in part A is to find the mean of x. So for part A, we need to remember that the mean of x is e of x. And the way that we find e of x, the mean, is we need to integrate x, f of x, with respect to x. And since we've got this piecewise function here, we need to find the mean of this and add it to the mean of this. So actually for this question, if I want to find the mean between 0 and 10 of this function, I've got to integrate between 0 and 2. Whatever the piecewise function is between 0 and 2, and add to that what I get between 2 and 10 for the piecewise function between 2 and 10. So let's do that. So between 0 and 2, it's going to be x times by 1/10. So that's 1/10 squared. And then between 2 and 10, that's going to be a quarter minus 1 over 40x, all times by x. So that will be a quarter x minus 1 over 40 x squared dx. Now we'll integrate our functions here. So for the first one, 1 over 10 integrated will be 1 over 10 x cubed over 3. So that's going to be 1 over 30 x cubed between our limits of 0 and 2, plus, and we'll integrate the 1/4 x here. So that will become 1/4 x squared over 2. So that's going to be 1/8 x squared, and then minus, then we'll have 1 over 120, because we're going to be dividing by 3, x cubed, and those limits are 2 and 10. So over here, this is where we'll carry on and work out what that is. So that'll be 1 over 30 times by 2 cubed minus, well, it's all going to be 0 when I substitute 0 in. So 0 plus, then I'm going to have 1/8 times by 1/8 times by 10 squared minus 1 over 120 times by 10 cubed. Now, when we substitute 2 in, we'll now get this 1 over 8 times by 2 squared minus 1 over 120 times by 2 cubed. And then we'll evaluate all of that and work out what it gives us. And that gives us an answer of 4. Now you may have a version of the book where it works this out and they've missed the 0 out here and they put 8 over 3 rather than 8 over 30 and end up with 32 over 5, which is incorrect. So this actually should be 4. So we've worked out the mean of x. The next thing we're going to do is to work out the mode of x. Now remember, for the mode, we want to sketch the function the PDF, because we may actually find that we can read off that function quite easily, particularly as these are two linear functions here. So let's start with the first part of the piecewise function. So when x is 0, we're going to have a probability of 0. So put that there. And then when we get to 2, so let's mark, let's say 2 on this axis here, and then we're going all the way up to 10. Now this isn't to scale, it's just a sketch. The value of the probability is going to be 2 over 10, isn't it, or 1/5. So I'll mark that on my axis here. Let's put that as 1/5. So the first part of the graph goes like this. Okay, so this is list linear as well. So if we put 2 into this, we'll get a quarter minus 2 over 40, which gives us a 1/5. So when we put 2 into here, we get a 1/5. We now need to just work out what happens when we put 10 into this. So a quarter minus 10 over 40, which is just a quarter. So we end up going back down to 0 again. So we can see that the piecewise function goes back down to here. So it's easy to see the mode, because remember the mode is the value of x at the peak. So I can see that the mode is just 2. So from sketch, mode equals 2. Now part B, comment on the skewness. Now to comment on the skewness, we write out the words mean, median and mode. We do those in alphabetical order. And we decide what sign goes between them. Now the mean we've worked out to be 4. The mode, we haven't worked out the median, but we did work out the mode was 2. So the symbol that would go between here is greater than. Greater than implies positive. So we can say since the mean is greater than the mode, the distribution has a positive skew. The distribution has a positive, try that out properly, positive skew. There we go. So you should now be able to do exercise 3D on pages 67 to 61 of the textbook, and there's a recap here, but this is just a repetition of what you saw on the first slide.